Hello everybody, welcome back to another video of me trying to learn the Zig programming language. I'm essentially trying to get better at trying to learn systems programming, and my language of choice to learn that has been Zig. I'm following this fun course called Ziglings created by Chris Bosch. It's a whole bunch of fun little exercises where you fix a program, you execute it, you get it to work, and it's logically organized, so you pick up on all the foundational construct and you can gradually learn harder and harder programs. So without wasting too much time, let's dive right into the code. Our previous few exercises in the quiz were pertaining to pointers. These are one of my favorite topics in low-level languages, and we looked into how pointers work, what are constant pointers, and finally we touched upon the topic of optionals. I got a decent idea of what optionals are supposed to look like, but towards the end I tried playing around with a few things and couldn't really completely get the concept, at least in one of the end quizzes. The quiz didn't have optionals, but I tried using it, and syntax got a little bit funky, but let's dive right in and let's take a look at optionals now. One thing I would like to add is that I have seen optionals before. It's not a new concept. It's just the syntax in Zig is slightly different with the question mark prefixing the type, but a lot of other languages have this to an extent. I believe Rust sort of popularized this idea of optionals, but C# and the other languages have had it for a long time with nullable types, where you can say int followed by question mark, which essentially means that you can either have a number or the absence of a number, which is the null keyword. And I'm sure Zig has a variation of that, or just a syntactical difference, but a similar foundational concept. Cool, let's dive into the exercise. Sometimes you know that a variable might hold a value or it might not. Zig has a neat way of expressing this idea called optionals. An optional type just has a question mark like this. Cool. So we have the variable foo, and this can either be a number or it can be null. Now foo can store an unsigned integer or null, a value storing the cosmic horror of a value not existing. Yeah, this is a fun call out, because generally when we write bigger and bigger programs, the nullability of variables, nullability of reference calls play a huge role in the design of our algorithms, and often a lot of mistakes happen when we do things like null overrides and other bad practices, which is often done to cut corners, and then it comes back to bite us down the line. So I do get this fun call out. Cool, and now we're assigning the value for the variable as null, since we've declared it as a nullable variable, and we've also initialized it with a number, but now we can reassign it to be null, or the absence of it. Cool. Now we have a conditional checking whether the variable is null. If it is null, we're saying begin screaming, a fun little call out of the joke. But yeah, this essentially represents how most of the branching occurs when, say, a network call is made and the network call fails, or the network call does not respond, and we sort of need to handle now our result that we were expecting. Technically can be an error union, but we could use null for the value that we were expecting. Cool. Before we can use the optional value as the non-null type, we need to guarantee that it isn't null. One way to do this is to threaten it with the or else statement. That's funny. Essentially what we're saying here is we have an optional which represents a value or the absence of it. And now by using the or else, we can say if the value exists, take that. Whether it's if we return it or assign it, in this case, it'll take that value. If the value is null, then it will take 2. So yeah, this is fun, straightforward syntax, quite similar. We'll see later on to one of the catch statements saying, hey, if this is an error union, if you use the value of the union, or we can do catch, if it's caught, use whatever value is specified to the right hand side of the catch syntax. Cool, pretty straightforward to what we've seen before. Let's look into the code real quick. We have a main function here. We're assigning a constant result, and we're assigning the value deep that is returned by deep thought. And it seems to be potentially either a number or a null value. Looking at this, we are forcing a null here. There's a bunch of funny text where the deep thoughts output has declined in quality, but we'll leave this as is. Sorry, deep thought. Okay, that's a fun little tidbit, fun little joke, sorry. And yeah, we're returning null. We'll assign the result to be null. That's okay. And now we have the answer, and it's saying, hey, we're assigning a nullable number into a non-nullable type. I'm pretty sure the compiler is going to throw an error, and let's see right away what the error is going to look like. So like run 045 optionals. Cool, we have a pretty straightforward error here. It's saying, hey, you're trying to assign the wrong type to the wrong type. Also, the compiler is telling us clearly what's wrong, and you can see that the first one's an error, indicating us breaking the rules of the programming language. And below that, there's more insight into it, what a potential fix could look like. There's a note saying, cannot convert optional to payload type. Cool. And it also says, consider using the dot question mark or else or if. So we pretty much learned exactly how to handle optionals. It's called out right here. So not only do we know what this particular example is about, we also know the next example. Very good. That's a good, well-defined explanation from the compiler helping us. So let's fix this. Immediately we can say result. The answer can be the result if it's not null, but if it is null, we'll say or else the number 42, and that's given in the instructions right here. Cool. Let me run this first. Sig run 045. Perfect. Now we have the answer, output saying the ultimate answer is 42. That makes a ton of sense. Let's see what explanation is here. It says options are a lot like error unions. Exactly, yeah. When I opened the example, I immediately saw that and I said, yep, that makes perfect sense. Likewise, the or else statement is acting like a catch statement. Yeah, pretty much we're replicating exactly how we would handle the catch shorthand notation for an error union. The only difference here is we just put a question mark instead of an error and an exclamation mark here. Syntactic differences to indicate two different situations. Error represents the failure of something, where null or optional represents the absence of something. Might sound strange for somebody who's never seen this sort of a setup, but I can sort of assure you, I guess, that there is a clear advantage that we'll see when writing larger and larger programs of uniquely identifying an error and uniquely identifying a null value, and they're not the same. Cool. Let's look at another example. Fun. So now that we have optional types, we can apply them to structs. Cool. So now that we have optional types, we can apply them to structs. Cool. The first time we checked in with our elephants, we had to link all three of them in a circle so that the last tail linked to the first element. We had to do this in the previous quiz because there was no concept where a tail didn't point to another elephant. Just to recap, essentially we built a linked list like this. Elephant 1 connects to elephant 2, connects to elephant 3, and then 3 essentially what it was doing here is going back and connecting to the first elephant, right? I was trying to do this. So we have one, element two, element three, and it's creating a circular loop. And we were forced to do this because we hadn't learned the concept of optionals. And I tried fiddling around with it. I didn't get the syntax right, but now we know better. We know how to use it so that we no longer need this sort of a circular loop. We can just do a straight line and say from element three, nothing else exists. Cool. We also have a nice handy shortcut here. Instead of explicitly saying bar or else unreachable, almost very similar to doing a try with an error union. I'm not going to write it, but we can do try and error union, where it honestly means either use the value held by the union. If there is an error, throw the error. Essentially what we're doing here, but we're doing it for optionals. Cool, that makes a ton of sense. Now, check out where we use the shortcut below to change control flow based on if an optional value exists. So we're going to see some examples of how the flow of control will happen depending on whether or not the value is null. Cool. Standard library, we have a struct here right off the bat. We can see that the pointer to the next elephant in the chain, this is incorrect because we're assigning it null, but the type says that it is not nullable. We know we have to make this change. But before we do that, let's see what happens by running the code. I'm not going to run it immediately because I know that there's a red squiggly here, which means we're broken the syntax of the language somewhere. So we do want to make sure that the syntax error is fixed first. But let's read through the code. We have three elephants, the structure initialized with values ABC. We have two calls to a link function. Essentially, it's taking A, connecting it to B, B connecting to C. We see the code here of how the linking happens, two pointers, connection between the two pointers, pretty standard stuff. And it also says, hey, by the way, if you try to link the third elephant, which is C, and you attempt to link it to a missing elephant. Essentially, if you try and explicitly link it to a null value, first of all, we shouldn't be doing this because we're already by default setting it to null. But in case you do that, it says that it's going to throw an exception, uh, throw an error, and that's because um, this shorthand means that if E2 doesn't have a value, which means if it's null, then it's going to call the unreachable keyword. Cool. Now we know why link elephants would fail. Let's look at the visit elephants function. This function visits all the elephants once, starting with the first element and following the tail to the next elephant. Cool, we have the first elephant here, whatever is passed in is assigned, and while the elephant itself is not visited, we'll continue in a loop, essentially a linked list, and we're using the visited flag to make sure that we're incrementing count and we're not repeating it. If it were circular, in this case, it's not circular. So check is pretty redundant. Right? Is it redundant? Yeah, I guess if you've already visited, they don't want you to continue. Yeah. Okay, let's print the elephant itself. We'll mark it as, hey, we visited it. And here, we're saying we should stop once we encounter a tail that does not point to another elephant. What can we put here to make that happen? If we wanted to stop, there are two opportunities. One, we can throw the unreachable code. That's the shorthand here. Let's go and run that first. We'll see a panic. Oh, my bad. Before that, good that we saw the error. We didn't want to fix it because we wanted to see the error. It says, hey, we're trying to assign null here. Clearly, this cannot accept null. And it's saying expected type is 046 optional dot elephant, but you're assigning null. Very interesting the way the compiler is throwing this error. It's saying, by the way, there's a structure called elephant, which is a type that the user is defined. And it belongs in the namespace, which is nothing but the file name, because we've defined it here in the file. Very interesting. Something that's a good learning for us. But the fix is straightforward. We'll put a question mark here. Let's clear the output, run it again, see what happens. Cool. Now it's throwing a panic and it's saying ABC was printed. And from C, we cannot go anywhere else. Unreachable code here, throw in a panic, right? Yep, throw in a panic. Now, if we read the hint, it says, we want to do something similar to that, but not exactly. We don't want it to panic because truly speaking, nothing went wrong. It's just that we've reached the end of our elephant chain. We wanted to gracefully stop running the loop. And the way we would do that is we would go from the shorthand, expand it to the more verbose syntax, and we'll say or else break. Again, we know that break is one of the control flow statements, as we call it, and it essentially ensures that the looping construct stops and the flow of control is transferred from outside the scope of the loop into the next line. So cool, let's run this. This should be a fairly simple fix, fairly straightforward explanation. Perfect, now we have A, B, and C printing. And just for the fun of it, let's go back to what we were reading here. We're attempting to link to elephants and it's gonna fail. Why is it gonna fail? Not because we cannot assign null to the tail of C. It's gonna fail because we're trying to access elephant 2 here, the missing elephant, but since this is null, we're going to reach the unreachable keyboard because remember, um, this this translates to E2 or else unreachable. Cool. So we're expecting a panic and we're expecting the panic at line 41. So let's run it. Perfect. We do see the panic, and it says attempting to use null value. And sorry, I said 41, it's 51 clearly. I mean, yeah, 41 is where we're calling it, but at 51 is where the error is actually thrown. Perfect. I think those two were really fun exercises to learn optionals. I think it was a lot of fun to understand optionals. Now, let's smoothly transition into another fun concept, methods. Before we even dive right in, let me recollect the distinction between functions and methods. And this isn't necessarily an explanation to anybody who's watching. It's more so for me because we want to take this slow. We want to understand and appreciate the language and not just treat it as another chore. The goal is not to learn the language. The goal is to retrain our high level, retrain our habit of programming in a high level language and thinking low level. So we'll take it slow. And I want to reiterate concepts over and over again, even if they're wrong, so I can correct them if they're wrong, and plus understand them deeply. So cool. That rant aside, functions and methods. So we've seen that in say JavaScript or anywhere else, usually functions are scoped to something, right? In Zig, previously we saw when we wrote a function, say public or private, or I don't even know if private is a valid thing, but besides the point. Um, Function, let me call this example. Now, this example function is scoped to untitled1.zig, right? Because it is in the namespace of the file name. The second thing, an important thing in object-oriented language, is everything is built around data, and that's what makes it good or bad depending on who you ask. And I believe methods are literally functions, but they are scoped to the type itself. We'll explore that concept more, but I just wanted to reiterate that to myself. Let's dive right into this fun example. So it says, help, evil alien creatures have hidden eggs all over the earth and they're starting to hatch. Before you jump into battle, you need to know three things. One, you can attach functions to structs and other definitions. Right off the bat, other definitions, they're talking about enums. Um, cool. We have a constant variable. No, sorry, that's completely wrong way of saying it. We have a constant identifier foo. We're assigning it the structure. Within the scope of the structure is a function hello. This function, which is part of this type that we just created, type foo, which is our user-defined implementation of the struct of Zig struct primitive. Hello is a method from the perspective of foo. Cool. And we can see here clearly, similar to almost every other language that I've personally tried, the identifier is foo, and the method is usually invoked with the identifier and the dot axis operator. Cool. A function is the member of a struct, is namespaced within that struct. And it's called by specifying the namespace and using the dot syntax. Yep, I just called it the dot axis operator. It's called dot syntax. Cool. The neat feature of these functions is that if their argument is an instance of a struct or a pointer to one, then we can use the instance as the namespace instead of the type. I see. Cool. I do understand that. Very, very similar is the concept, say in C sharp, of a static class and static functions. So static classes and static methods, my bad. Static methods are scoped to the namespace of the class, whereas instant methods can be accessible by objects of the class. Something very similar is happening here. There are subtle distinctions, but what's happening here is we're creating a structure and we're saying, hey, by the way, the first argument in the method is a reference to the type that we just created, bar, or a reference to the pointer of the type. In this case, when we initialize bar here, we can call all of these methods through this bar instance destruct. Yeah, I was thinking of taking a quick aside, but yeah, it makes sense. Essentially, we have the concept of namespaces. And if we say struct of something, we'll say, I will use the Zig way of doing things. We'll say animal, we'll say struct, right? Number of we'll use the right idiomatic way of doing things. Lex, unsigned integer of 8 bits. We have a property now, and then we'll have a function. We'll say publicly accessible, and we'll say it is hello, right? And we'll say it's void. Nothing is returned. And we'll say standard dot debug dot print this animal has actually, let me not even do this. Yeah, I guess we can do it. You num anonymous type here. I kind of want to run this example. Yeah, I really want to run this. Let me save this. Before I do, let me also import it. Import the standard library. I like Zig way of writing imports. Certainly more fun than writing it in JavaScript. Let me try and save this file. Oh, I don't know why that's not working. Let me copy this code. I'll say test.zig. Say test2.zig. I don't know what's happening with this. We'll worry about that later. Unsigned integer of 8 bits. Oh, my bad. What's the error here? Expected function or variable declaration after pub. Oh, my bad. I forgot the keyword. Public function. Cool. Did we get that right? And we're displaying the number of legs. Use of undeclared identifier. Let's say by default. I wonder if we can even do that. Ah, I see, because it's not an instance. Okay, I see. Let's just accept it then. We'll accept number of legs. And we'll say unsigned integer. Actually, we'll say input legs. We should have said limbs, but that's fine. Can we directly access this? Yeah, makes sense. And this is essentially why we use an instance of a struct. Cool. I'm going to remove this because there is nothing we can send here. Use instance method instead. Cool. Now let's create an instance method. Pub function print legs. So we'll say, we don't have to assign anything here. We'll say standard.debug.print this animal has legs. Dot access operator, and we can use number of legs here, I believe. Cool, we did that. Let's come here. Again, this is a void function, void method, my bad. And we will accept an animal as its first argument. And the way we would say is Annie is an animal. right? And we'll access number of legs by saying any dot number of legs. This is the importance of instance methods. And the advantage now is, let's invoke this. I know we're going on a massive aside here and we should trust the process and not do this often, but just for the fun of it, we'll say const dog, a man's best friend. Let's say animal. We'll define the struct. We'll set the number of legs to 4. Actually, initially, let me set it to 100. Actually, let me not set it to anything. It's 4. And I will say dog dot, I can call print legs. Yep. What's happening here? Oh, it's expecting me to assign to a variable. My bad. Let me put this in the main function, which is the entry point to our program. Public function main. I don't need this. No error is going to be thrown here. It's just going to be a void. Cool. Let me just run this, see what happens. Zig run test2.zig. Perfect. It says this animal has 4 legs. We'll do \n, that way we don't have the prompt character also printing there. Cool. I am curious. Can I do dog.hello? Now, in C# and other languages, if hello is sort of defined as a static method, this would not be allowed. Let me see what happens in Zig, just so I can understand. Right. It says hello cannot be called by the instance of the animal structure because it is not an instance method. Right? There's no field or member named hello in test2.animal. However, if I do this and I say animal.hello, this should work. Perfect. That works. That works exactly how my brain expected it to work. And that's kind of nice. Works similar to other languages, but yeah, I believe it's gonna be wrong to say structs are similar to class because struct is technically a value type. I believe they're stack allocated. I don't want to push the boundaries of my. I don't want to pull out these things out of thin air, but I believe it's sort of called loosely a stack allocated. Classes are more dynamic in nature, heap allocated, but I don't want to go into it without actually understanding it. But cool. Maybe we should contribute an example to Chris Bosch's repository. But that's fun. Let's go back to our original example, trust the process, and do that instead of making up our own stuff. Okay. We were here. We were looking at, we looked into what instance methods are. Yeah, this makes sense. In C sharp, there's a thing that happens in the background. I believe it's called self here, but this is also a special sort of a keyword in a lot of languages, wherein when something is called like this, it actually means that the first argument would be this itself. That way you can access values assigned in this memory location and its properties. Cool. We do understand it. I get it. Let's continue. Notice that the name of the parameter doesn't matter. Some use self, others use a lowercase version of the type name, but feel free to use whatever is most appropriate. Cool. Okay, you're armed. Now please zap the alien structs until they're all gone or the earth will be doomed. That's fun. Let's see. We have aliens have a health and they have a hatch function, which essentially returns the structure alien. And it says the health of the struct is strength into 5. Now we have a heat ray, which is our weapon of choice, our trusty weapon to zap the aliens. And now we have struct, we have damage that a weapon can cost, and we have a zap function essentially that eliminates the alien's health, reduces the alien health, and the alien's health will decrease depending on the damage. Now, the damage is greater than or equal to the alien's health. The entirety of the alien's health is removed. We have minus equal to here, so it becomes 0. Otherwise, the total amount of damage from the weapon is subtracted from the health of the alien. Cool, we understand this. An array of aliens, and we are creating aliens using the hatch function. Now, we could have quite easily done the same exact thing by using syntax like alien dot health equal to 2. We could have quite easily done this, but you see this is more logically sound, and it's a shorthand. There are more use cases for it. In C#, we do tend to use static create functions in ORM, in the ORM layer. Someone who doesn't know, it's again object relational mappers. I know there's a lot of strong opinions on why we should use, whether we should use relational mappers to the database or not, but that's a separate conversation. But cool, we get what's happening here. We have a bunch of little aliens created. Again, this returns the structure. The health function is returning the structure, and that has been captured in this array. And the size of the array is inferred, but looks like there's 6 elements. Cool. Now, the total number of aliens alive is 6. Now we have our heat ray, and the damage of the heat ray is 7. Cool. Yeah, we'll loop through the alive aliens. Greater than 0 means it'll run as long as there's at least one alien alive. And immediately inside, we're saying the number of aliens alive is 0, which is just an initialization of our loop control variable. And we'll say, we'll loop through all the aliens and we'll start zapping them up. How do we zap them? Cool. To zap an alien, let's see, the zap function has a reference to self, which is of the same type, which means it's an instance method. Now let's create we have the instance here. So it's going to be heatray.zap. What are we zapping? It accepts the first argument is passed now. The dot access operator automatically passes it. And the argument of the function would be the alien. Cool. We're looping through each alien, and we're gonna zap the alien until its health goes down to 0 or less than 0. And if the alien's health is greater than 0, as long as it's greater than 0, we will say, hey, the number of aliens alive is 1, increases by 1. Cool. And we'll go through the loop for each alien. We're going to start zapping, and we'll know initially 8 aliens were alive. Now when we set the loop control to 0, we'll know how many aliens are eliminated by our zappers. And it looks like it's almost like a Western movie. We get one shot, and we either zap them or they survive. And we're printing them out at the end of each iteration. At the end of this, we'll print out and see how many aliens were survived on the first shot, and first one shot per alien. And if the aliens are alive, we'll continue on over and over again to see when it all ends. Now let's run this code. 047. Perfect. Look at that. Initially, we had 5 aliens, 4, then 1, and 0. We went through a loop inside a loop. Yeah, that's a fun little exercise. I believe we have a better understanding of methods and how they're scoped either to the instance or to the struct. But yeah, that's a wonderful, wonderful example, an excellent way to teach us about methods. Great work to whoever came up with the example. Now, let's look at the next example on methods, and then we'll do a quick quiz and call it there. We're a little over time, but that's okay. It's a fun exercise. We're not going to complain. Now, cool. Now that we've seen how methods work, let's see if we can help our elephants out a bit with some elephant methods. Cool. We have the standard library, and we'll say, hey, elephant, it's a structure. It has a letter identifying which elephant it is. There's a tail, which is a pointer to the next elephant in line. And we have the visited flag here, which says, have we seen this elephant before? Um, Very often in programming, for somebody who doesn't know, I'm sure most people who would stumble upon this video probably know more than I do, but just in case somebody is looking at this for the first time, and for my own reiteration, usually in programming, we always have some sort of a flag variable, as we call it. Flag essentially is a boolean of some sort that indicates, say, have you visited this, or have you already processed this element, and things like that. And a boolean variable used for tracking an operation is usually called a flag. It's not a hard construct, more of a conventional name that programmers treat that as. Cool. Now we have a new elephant method here, and this straight up, since it's the first argument is the elephant's pointer as well. We know this is an instance method. I quite like this precise writing of code. Instead of having uh, keywords like static, or not having static to define what is an instance, or a static variable, or a class instance method, or a class method. And those who are from an object oriented language will know this. It's that instead of having that background magic translating what static means and then actually going and appending this type as the first argument, in Zig we're precisely specifying it from right off the get-go. Um, Kind of makes sense when people say Zig is precise, Zig is precise. What does that mean? This is an example of it. And yeah, I do appreciate this. We're teaming with the compiler almost. Cool. We have the public function get tail, and here we'll pass in a node, and we'll get the value of the next node in the linked list, which is, we have this an elephant, get the tail, and we're going to say either get the next one or go to a state of panic. Cool. And now we have an hashtail function that says, hey, if there is no next elephant, return, if there is a next elephant, return true. If there is no elephant after this in the chain, return false. And we will use this as a guard before we call the get tail, I'm sure, just looking at it. Cool, we have the visit function. Again, instance method. I need to stop using the word function. It's a method because it's scoped to the struct type. Cool, we have we can set whether visited is true using this, and then we also have a print instance method. What we're doing here is we're going to say we have a constant which is a character unsigned integer of 8 bits. It holds a character, and it says if if the elephant has already been visited, we're going to use v to say, hey, visited, otherwise there's just an empty space. And we'll print out the elephant letter along with whether it's visited or not through this character. Makes sense. Now, we have the main function, we have a bunch of elephants declared, and we're going to say the first elephant is connected to the next elephant, and the next elephant is now connected to C. A connects to B, B connects to C. I kind of want to make a circular dependency here, but that's fine for now. Let's see. Visit elephants. So now we have, we're starting from elephant A, and we'll say go through, as long as it's true, an infinite loop looking at this condition. Uh, and we'll say, hey, print out the elephant name and mark it as visited. And then we'll go and say, get the next elephant or stop. So we'll use the guard to look at whether it has a tail. If it has a tail, we will do e dot, what's it called? Get tail. Or we break. Perfect. That makes a ton of sense. Instead of using optional, we're making a safe guard. Let's run this piece of code. Nice. We can see that we went from the first element to the next elephant to the third elephant. That's really fun. We went and we found a different way of writing the same thing we previously wrote. I like that the examples have been quite consistent. Um, Makes it easier to compare and contrast. A lot of fun. Very, very good examples here. Okay, let's see. Now, Zig's enums can also have methods. This comment originally asked if anyone could find instances of enum methods in the wild. And the first 5 pull requests were accepted, and here they are. Cool, let's take a look at this. Oh, there's a bunch of comments. I'm going to click on all of them. And then we'll go and see them. Let me switch over to the browser. Let's go through them one at a time. Okay, so now we have an enum here, and we have a bunch of different enumerations here, different languages it looks like, C, C++. What is H? I don't know, Haskell. No, it's probably not Haskell. That's a bad joke. Cool, and we have some methods, scope to the struct. Let's look at the next one here. Oh, all these are the Zig standard library. Ooh, okay. Config. Config is an enum too. And config is calling first argument is config itself. This is an instance method. Pretty cool. We see a bunch of examples. Oh, this is a big enum. Cool. Fun. I think we sort of get the idea. Unsigned integer of 5 bits. Is that it? Oh, I didn't even know that. Cool. Registers. This is memory registers. It says Arch 64. Oh, okay. Pretty cool. Our first exposure to some low-level systems code here. Interesting. A lot of fun. Cool. Let's get back to our code, and let's now take a quiz. We learned a lot of fun stuff. Let's actually give me a second here. Didn't we have like the visited thing? Did we miss something? Never mind. Let's look at this. Oh, yeah. This example will use that V character that we had for the visited. So trunks and tails are handy things. From Holding Hands by Lenor M. Link. I hope I pronounced that right. Lenor M. Link. That sounds about right. Now that we have tails all figured out, can you implement trunks? Right off the bat, I really like whoever wrote this particular exercise. They made us implement arrays, then showed us the concept of nodes and links, and made us implement a linked list. Literally made it so fun that we implemented traversal along the linked list. And now they're asking us to do a reverse traverse. So there's an elephant and its tail is connected to the next elephant. Now, how do we navigate from trunks? You go all the way to the end, and now you go from the trunk of the last element, go to the previous one, and to the starting one. Very, very, very fun exercises here. Really appreciate the thought behind writing something so cool as this. Very appreciative to Chris Bosch and the whole team behind the open source guys behind Ziglings. Cool, we have a standard library, we have the elephant struct, and we have a bunch of properties. We have the letter, we have tail, which is the nullable link to the next elephant. We have the trunk, the nullable link to the previous elephant. A doubly linked list, right? Fun. And now we have the visited property that indicates whether this particular node in this linked list or whether the elephant was visited before. Nice. We know what the get tail does. We've seen this before. We know what the hash tail does. Seen this before. Uh, Fun. Now it's saying write the code for the elephant's trunk method. Is anything implemented? We've already seen here we have three elephants. A, B, A is connected to B, B is connected to C. Now then B is connected to A and C is connected to B. The reverse connections. Cool. Let's visit elephants that essentially, while it's true, goes from the first elephant and follows the tail. When that's done, it comes here and says, while it's true, since E would now be at the last element, it'll go backwards and say, hey, if it has a trunk, go backwards. Looking at this, we know exactly what to do. We're essentially replicating what we had here. Let's write these instance methods. Public functions, we'll set get trunk, trunk, trunk. We'll say self, seems like a good convention to have. Elephant returns an elephant. Now it says return self dot trunk. Now we do want to make sure, since trunk itself is nullable here, right? Hover over this, you see that it's nullable. We want to ensure that no null value is returned because we have a separate guard. We'll do the dot access and say if it ever turns out to be null, throw an unreachable panic. Now do hash trunk to see whether a trunk exists. Again, we accept a pointer. We'll return a boolean and we'll say if, actually we'll just directly compare and we'll say if trunk not equal to null, right? Perfect. I think we have our solution, very straightforward. I believe it's going to be something like A, B, C, and then CV, BV, AV, to say that, hey, we have visited it. Because if you look at the visit function, print function, we're also using v's to append when we've already visited it. Let's run this code. Perfect. We traveled unidirectionally from first to last, and they utilize that bidirectional doubly linked list structure to go from the last node to the first node. Very, very, very fun exercise. Brilliant, actually, the way the whole thing was set up. I'm, again, deeply, deeply appreciative of the wonderful folks over at Ziglings, Chris Bosch again. Looking at this, it's been I think created a couple of years ago. Okay, that's a lot of fun. And they're still constantly updating and cleaning it up. Very, very grateful for Ziglings. We'll end our lecture there, slightly over 30 minutes. In fact, we're already at 60 minutes, nearly an hour, but can't complain when the exercises are so much fun. Again, want to call out the really incredible and smart folks at the Zig Foundation building this wonderful language. Um, I am very grateful that we have something similar to C. That is, I do not want to comment on which is better, whether this or Z. I am really appreciative of all languages. This is a new way to learn, a new way to think, and I'm really grateful that the Zig community is very outgoing and they're educating all of us, getting us easily, giving us an easy ramp to learn the language through things like Ziglinks. Um, yeah, it's been a lot of fun. I'm gonna call it there. See you all in another video. Bye.